We physicists have waited 100 years since 1916 for this photograph.
Over the years, scientists have argued that black holes either have a point of infinite density at their center or an event horizon, a boundary beyond which nothing can escape. But, all thanks to Michio Kaku, we now know what's inside of them.
We think there are many wandering black holes, smaller black holes, in the Milky Way galaxy. And so we have to realize that these monsters are in our own backyard.
Almost everyone knows that black holes are among the most exciting and mysterious cosmic objects. They are incredibly powerful but almost invisible. Previously, we used to know very little about these mysterious things, but because of decades of hard work, we now have some fascinating insights. Here's everything you need to know and more. In our everyday understanding of the physical world, everything seems to be made up of specific bits or pieces. Think of these as particles and their opposites, which we call antiparticles, or a fixed amount of energy. Moving to the quantum realm, some properties always remain the same. They don't vanish or appear out of the blue. Electric charge, energy, and momentum are examples of this. No matter the circumstances, these qualities stay constant. Now, things become more mysterious when we discuss black holes. According to the theory of general relativity, everything inside a non-spinning black hole collapses to a single point with no size. This idea is mind-bending. On the other hand, if a black hole spins, everything inside it gets stretched into a super thin ring, which is again challenging to grasp. To add a touch of humor to this complex topic, comedian Stephen Wright once joked about black holes being places where God tried to divide by zero, which is also true. But there are strong reasons to doubt that even the hope that quantum gravity will save us from a singularity is realistic. Our awareness of black holes has grown, but many of the most basic questions about these intriguing and strange objects are still puzzling most people. These mysterious giants are thought to form when massive stars explode as they near the end of their lives. The aftermath of this violent process is a hole in space-time, although the word hole can be misleading because black holes are not holes at all. They are spherical structures made of some mysterious, as yet unidentified kind of matter. And so, because of their enormous size and weight, they stand out dramatically against the background of space. Their immense mass, which can also surpass millions of solar masses, gives them tremendous gravitational power, leaving a profound bend in space-time and attracting neighboring matter like a gravitational magnet. Any celestial body near one of these massive stars will then experience an irresistible pull as the universe moves around them, where their powerful pull may trap anything from clouds of dust and gases to whole stars and even planets. The great gravity still ensures that the journey will be filled with danger. Because of the difference in gravitational pull between the top and bottom of an item, matter undergoes a process of spaghettification, where it becomes elongated and warped. As a result, once these things pass the event horizon, they enter the black hole's mysterious interior. According to standard physics, the consumed components within the black hole then undergo an astonishing transformation. The singularity is a hypothetically indefinitely dense concentration of information from which all other information disperses. Yet, Michio Kaku provides a counter-argument, indicating that the current understanding may be incorrect. Black holes, intriguingly, spent a significant portion of their history existing only in mathematics. It took nearly 6 decades from 1916, when Albert Einstein first proposed the existence of black holes in his groundbreaking theory of general relativity, until 2015, when a genuine black hole was confirmed. Then, in the 1970s, scientists' attention was riveted by a mysterious star called Cygnus X1. The strange behavior of this star finally led scientists to conclude that it must have a large companion that they could not see. Additionally, after years of careful observation and theoretical calculations, Michio Kaku's long-held goal of confirming the existence of the first black hole was finally realized.
This photograph is the smoking gun. First of all, the black disk in the center is the event horizon, the point of no return. You fall through that event horizon and you never come out.
You see, Cygnus X1 is a stellar black hole that formed from the catastrophic end of a huge star and has a mass of 15 to 20 solar masses, which is small compared to other black holes. These days, our inventory of known black holes is much larger than that of any one isolated discovery, a monument to both the astronomical development of human knowledge and the ever-present appeal of these mysterious cosmic creatures. Thousands of these cosmic abnormalities have been detected throughout the Milky Way galaxy, sparking theories that their numbers may potentially reach into the millions quite soon. Meanwhile, many galaxies, including our own, are believed to contain supermassive black holes with masses of 1 million or more suns at their centers, where about 50 years after the first black hole was discovered, humanity reached a major milestone by successfully photographing one of these cosmic giants. Of course, astrophysicist Michio Kaku, a longtime proponent of the black hole theory, was incredibly enthused by this visual show. So, Kaku provided a novel viewpoint on the mysterious black hole interiors, which is consistent with the idea that they arise from the remains of enormous stars.
We now have bagged some of the biggest black holes ever recorded in the history of science that have gobbled up over 20 billion stars. What a feast of astronomical activity.
Black holes, according to Kaku, who is a staunch supporter of traditional experimental physics, break down matter into its atomic components. These celestial bodies, based on Albert Einstein's general theory of relativity, have gravitational forces so great that not even light can escape. We also know that light is a fundamental constituent of all matter, but the information is far more fundamental. Anyway, in the realm of quantum mechanics, to which Kaku also sticks, knowledge is indestructible. It is the fundamental building block of matter. That means, if a black hole were to swallow and dissolve matter into pure information, that information would be lost forever if it didn't escape the event horizon. And for those of you unaware, the information paradox refers to the fascinating difference in outcomes for matter and information. Throughout his distinguished career, Kaku has also made solving the problem his primary focus. Many of his proposed solutions include using quantum effects. The landscape of quantum physics opens up to the potential of parallel universes, alternate timelines, and even time travel, which states that the common view of black holes as cosmic prisons that swallow everything up could be challenged by these quantum strange behaviors. Moving on, Kaku's creative ideas allow for the possibility that black holes are something else than cosmic vacuums. He believes that they have the potential to act as massive portals, or even pipes or wormholes, to other dimensions and faraway worlds. Not to forget, is it possible that there is evidence pointing to the fact that our reality is even more astounding than we have conceived it to be? What if we are living inside the limits of a black hole? For one, it is strongly evident that black holes are regions in the cosmos where the pull of gravity is so strong that it warps the very fabric of space and time. And as proven before, once something falls into a black hole, not even light can escape its grasp. So one way of looking at things is to consider the possibility that a black hole once swallowed up the Earth in its distant past. But then, the results would be devastating. When the object approached Earth, time itself would slow down, and the enormous gravitational attraction may stretch everything into bizarre forms like spaghetti. And even if it were to survive such a spaghettification, the Earth would eventually fall into the microscopic singularity, where it would be destroyed by gravity forces that cannot even be imagined. On the other hand, this scenario is not realistic because the force of a black hole would destroy Earth in a matter of milliseconds. One theory, which is separate from the others but no less captivating, is that the Earth may have originated inside of a black hole. Mathematically speaking, there are a lot of similarities between the Big Bang and a black hole, which is a fascinating comparison to make. According to it, the universe expanded from a point of singularity where it all began, in contrast to the process by which a black hole shrinks to an extremely small and densely packed point. Now, one school of thought proposes that the Big Bang itself was the singularity of a black hole that existed within a bigger parent universe, where the compacted core eventually exploded, giving rise to the beginnings of a new universe within the boundaries of the black hole. This theory, which has been given the name Schwarzschild cosmology, also argues that the expansion of our universe takes place within a larger, more advanced parent universe. This idea then raises the possibility of several universes coexisting within one another, much like how a set of Russian nesting dolls would arrange its contents. And even though traveling backward via a black hole is an extremely unlikely attempt, given that even light has trouble doing so could potentially reveal realms that are beyond our ability to imagine. No wonder. A question that has scientists up at night is whether or not data that disappears into a black hole can ever be recovered. Yet proving the reliability of this idea is extremely difficult because we cannot yet travel past the event horizon of a black hole. So, in the unlikely event that our planet gets swallowed up by a black hole, the size of the resulting void in the cosmos is thought to be enormous, since it exceeds the size of planets and solar systems. If it were any larger, obvious traces of a rotating black hole would have then been found, or observable effects, such as time dilation and the stretching of matter, would have become obvious as humanity walked inside it. For instance, if the Earth were to find itself inside a black hole of the same size as the Earth, then anyone traveling around the world would experience obvious effects of tidal forces, such as spaghettification and time dilation. As a result, any black hole that could house Earth would have to be of such a massive size that our ability to sense the gravitational irregularities it causes would be severely compromised. Meanwhile, the search for our world's origin is made more difficult by the fact that if Earth were to exist within the universe of a black hole, its people would be ignorant of the presence of a parent universe. Despite this hypothesis continues to attract people because it offers a tempting possibility that sparks the imagination. Having said that, Michio Kaku claims that in 1963, New Zealand mathematician Roy Kerr provided an insightful picture of a revolving black hole by applying Einstein's gravitational equations. Yet, a remarkable abnormality emerges in his answer, suggesting that an Einstein-Rosen bridge could form inside a black hole and lead to a white hole in a parallel universe. On top of that, Kerr realized that the collapse of a spinning black hole would not result in a point, but rather in a ring of fire. This ring's rapid spin would then counterbalance its implosion, leading to an unexpected result. An object thrown through it might cross the Einstein-Rosen bridge and emerge on the other side of the wormhole undamaged. Not to mention, this mysterious device, commonly known as a wormhole, can connect several parallel universes or far-flung areas within a single one. This occurrence can be then imagined as a doorway into a parallel universe, similar to Alice's looking glass. The Kerr ring further connects two universes like Siamese twins sharing a single link, allowing travelers to travel between them as easily as if they had passed through the looking glass and arrived in Wonderland. Of course, such daydreaming led to speculations of black holes and wormholes as potential portals to other areas of our universe, or even time machines for exploring the past. Skeptics, despite this, point out problems that could arise, which means caution is warranted. Now, there have been hundreds of proposed answers to the wormhole problem, but some critics argue that these shouldn't be quickly written off as wishful thinking. So it's eventually possible that anyone who goes into the wormhole's opening might die due to stability issues and the powerful radiation and subatomic forces that surround it. And let's not forget, in the middle of heated discussions on this topic among physicists, a frustrating restriction becomes apparent. It is also impossible to settle the debate once and for all because Einstein's calculations fail at the heart of black holes and wormholes, where radiation and subatomic forces can reach such extremes that they could cause the collapse of the entrance. And because Einstein's theory only deals with gravity, it leaves out the complex quantum forces that regulate radiation and subatomic particles, leading to the current situation. Undoubtedly, black holes pose an enormous challenge to human understanding because of the complex nature of the cosmic work in which they are set. These beings can create severe feedback loops that twist the very fabric of space-time, since they were formed by a union of matter in an extremely tight region. The event horizon, which is the border that separates the possibility of escape from the point of no return, is also the moment where light stands on the brink of the singularity's pit. Though the realm of general relativity collides with the mysterious realm of quantum mechanics, creating a junction that cries out for a deeper level of comprehension. Still, the interplay of space-time geometry is elegant, but it runs into a problem at this point. Today, we know that the classical concept of gravity and the puzzling complexities of quantum phenomena come together inside black holes to form an issue that can only be described as a mystery. So when we make an effort to decipher their hidden mysteries, we run up against the limits of our knowledge, which are characterized by deep conflicts and the appealing possibility of unknown lands. Though an activity that may one day throw light on the mysterious core of black holes and transform our view of the universe itself, the search for the unattainable bridge between general relativity and quantum mechanics is being driven by the fundamental concerns that these cosmic objects offer. The exploration of black holes also continues to push the limits of human reasoning, showing the limitless diversity and power of the cosmos even as we stand on the edge of a discovery. But who knows, one day we might just solve it inside out. Will Michio Kaku and others who have been at it for quite some time be able to figure out what stays inside of the black holes? Let us know your thoughts on it in the comments below, while making sure you can catch us for more by clicking on the bell icon.